Hello all, welcome you to this Docker demo training session. Here we will discuss about what we are going to cover in this training, what topics and what concepts of Docker we will going to discuss, and we're going to discuss about the projects what we will cover. We're going to discuss about the basic Docker architecture, Docker concepts of images and containers, and then Docker CI/CD process. So let's start this session. About myself, I am a senior site reliability engineer right now, and I have 5+ years of industry experience. I am working a reputed company right now, and I have very good experience in production grade infrastructure setup, maintenance, and management of Docker-based infrastructure setups. I have 2+ years of professional experience in training, and I have given many trainings to the working professional as well as freshers. I have given online training as well as on offline training also. I am proficient in Docker, containerization, Docker CLI, Dockerfile, Docker registry, Docker build, Docker CI/CD part, Docker images, and I have production grade experience in Docker architecture, Docker environment, creating CI/CD, building images using Dockerfile, and have very good experience in debugging and troubleshooting. I have done debugging and troubleshooting in live infrastructure, and I can help you in preparing the interview for Docker interview questions, practical sessions, live demo on how questions are being asked, how we have to answer them. Let's go to the next slide, which is the scope of the demo. In this demo, the scope will be as follows. In the Docker demo, we'll cover how to set up Docker environment and we'll showcase below features of the Docker. So the features will be like what is Docker. So here we'll discuss about what exactly Docker is, what it do, and how it's changed the behavior of application deployments, infrastructure setup in cloud environment as well as self-hosted environment, difference between VMs and containers. And so difference between VMs and containers, when we talk about, it's like earlier we were using virtual machines to deploy our applications to run our servers, but now containers came into the picture. So how container changed the world, what's the difference between both of them, why we have adopted containers. Then we talk about how application runs in a Docker container. We talk about networking, volumes, and environment variables in Docker. So how networking works, how the communications within the Docker container to the internet world, how it works, how you can expose your service to the internet world, how you can mount your volumes, how you can attach a file to a container, and then how we can pass environment variables in the runtime as well as while configuring the applications also. We'll talk about Docker images, layers in Docker, image building process, and Dockerfile. So Docker images, we'll talk about what is a Docker image, how it works, what behaviors Docker images precise, as well as we'll talk about how we create the Docker images. Then we talk about the layers in the Docker image. We'll talk about image building process, like how for our application, for our source code, for our APIs, how we build the image, and then we'll talk about writing Docker file, how we can write the Docker file, what are the best practices followed for Docker file. Then we talk about container orchestrations provided by Docker. So they are Docker Swarm, Docker Compose, and then we'll talk about writing Docker Compose files. So Docker Compose files, in writing Docker Compose files, we'll talk more about how we can configure multiple applications in our Docker infrastructure at the same time. Then we'll talk about debugging and troubleshooting. In debugging and troubleshooting, we'll also showcase you the live debugging and troubleshooting of any application. If an application's got some issues, how to troubleshoot it, what will be the first point to check, what will be the remediations for each kind of errors and issues we are getting. Then in the course outline, we'll cover what and all chapters are there in Docker. So Docker, it's very huge infrastructure, I can say. So it resides almost everything of a system, of an operating system. So that's why the concepts course will be divided in discrete kind of chapters, where each chapter will have its own meaning. So yeah, so the course outline will be as follows. Here, the first thing will be introduction to the Docker. Basically, like we'll talk about what as said in the demo outline. It will be like what is Docker, how Docker works, and then virtualization and containerization. We'll talk about virtualization, we'll talk about containerization, we'll talk about Docker architecture, how what's the architecture Docker has built upon it, and then the Docker registry. Docker registry is basically where the images are getting stored. Then installation of Docker on AWS cloud as well as on our self-hosted machines also. We'll go more about the CLI. We'll do hands-on practices on Docker CLI. We'll get to know how we run commands in CLI for Docker. Then we'll know about the Docker file, using the Docker file, how we can create the images, how we'll be able to write Docker file for our particular application, how we can write a specific Docker file. Then we'll talk about how we can create container, how the push commands in Docker work. Then we'll talk about the images in the next chapter, where we'll talk about the layers of the image, we'll talk about the containers, we'll talk about the portable lightweighted containers. In the next chapter, we'll talk about Docker Advanced, where the Docker commit command, Docker push on the registry server, and public and private will talk. After that, it comes the Docker build, very important thing, because we have to know, whenever we got the concept of Docker, we have to know how we can build our own image, how we can build our own application source code and run it in a Docker container. So for that, we need to know how we can build the Docker image. So in the chapter 10, we'll discuss about that. We'll discuss in detail about certain applications where Java Spring Boot, Python apps, .NET, Node.js, for all these we'll write the Docker file and we'll do the building part. We'll try to spin up the container, we'll try to run the application, and we'll try to check the features if they are working fine or not. We'll also try to make it automated way, like how we can automate it. Then we'll talk about Docker volumes and bind mounts, where where we'll be talking about how storage works in Docker, how it stores the files and data in our system, how Docker image sizing and how the containers data are stored in Docker as well as in our system. And after that, we'll also discuss about how we can attach volumes, where we'll be attaching a storage, a directory, a file in our Docker container at the time of running as well as at the time of configuration. So in this chapter, we'll more discuss about how storage works, and this will cover the storage in operating system also. Basically, like how storage in operating system works. We'll discuss both so that we can get to know how the both of the like Docker and our operating system, traditional operating system, how both of them are same with different kind of processing, different kind of operations. Then we'll talk about Docker networking. In Docker networking, we'll talk about how communications within Docker work, how Docker handles networks, how Docker handles the ports you have exposed, then how applications are getting communicated to internet, and how it's basically like how you can expose the port to your for your application, how you can deploy your web server, and it can be accessible to public or it can be accessible to certain kind of users. So all these things we'll discuss here, as well as we'll also discuss about what and all security features of the networks available, what kind of network security you can apply on your container, what things, what rules you can apply so that your containers could be secure and it cannot be get exposed in the bad internet world where you can get DDoS attack, you can get Trojan detection attack. So we'll discuss about all these things also. Then we'll discuss about Docker Compose, where so Compose is basically, if you see, Compose is just a kind of extension where we use to define the container orchestration management, where we can say that if we are running more than one containers, how we can manage it effectively. Because if you see the Docker CLI, so for running spinning up each containers, spinning up the dependencies of that containers, you'll have to run each container command separately. You'll have to create containers separately. You'll have to pass all those environment variables, volumes, and port mappings separately. But using Compose, we can configure all these things, all these behaviors in one configuration file, and we can spin up all the configuration in one shot only. So here we'll discuss about how we can do it, how we can configure our application, how we can configure more than of a container of containers in a single configuration, where we can deploy all the dependencies in one shot. We'll talk about YAML, how what is YAML file, how YAML file works, how it comes into the picture, how it helps Docker to write compose effectively, and then we'll showcase how we can deploy microservices based applications in Docker Compose. So that's what I talked about earlier, like how we can set up, how we can write our configuration effectively in Docker Compose so that it can deploy all the applications in one shot only. After that, we'll talk about the Docker Swarm cluster management and orchestration. So Docker Swarm is also a kind of cluster where we can have multiple compute resources and we can deploy multiple containers and a fleet of applications and containers in our Swarm cluster. So we'll talk about creating the multi-node cluster in production grade environment, and we'll showcase that also. We'll discuss about each and every aspect of creating multi-node cluster in Docker Swarm. And then we'll talk about the Docker Swarm installation and concepts. We'll try to install a mini cluster in Docker Swarm and we'll try to deploy our applications. Then we'll have practice test and interview questions, where I'll be creating certain questions for the practice, as well as I'll be giving you some tasks which will be basically like how to create applications. I'll be giving you a project where you'll have to set up you'll have to set up the application code, you'll have to build the image, you'll have to spin up the container, then you'll have to configure. So you'll have to also write the Docker file for that. You'll have to write a compose file where we'll build all the dependencies of that application and try to deploy in one shot. After that, we'll talk about the interview questions, how interview works for Docker, what kind of questions they are being asked, what answers you have to put up, what kind of scenarios where they will ask you different questions, and how you can dig more into give more specific answers and with the deep knowledge, and showing them that you are having very good hands-on experience, you are having good knowledge on Docker. Now let's talk about the architecture of Docker. So basically, what's the architecture of Docker? Docker is basically built on the architecture of operating system. So earlier we were deploying all our applications in a virtual machine. Before that, in a legacy system, we were having a server running, physical server running somewhere. We are communicating with it via the proxy server, and then we are deploying our application in those remote servers. After that came the virtual machine, where virtual machine encapsulates all your operating system based files and it create a overlay of operating system in your host system. After that, the container architecture came, where the Docker came into the picture. So how Docker works? So Docker is having mostly three parts: client, host, and registry. So client is the one, we can say, a terminal or a remote API which calls actually our Docker commands or our Docker server or the Docker daemon. It communicates with the Docker daemon and it gives commands to the daemon, and daemon start processing it and then doing the operations. So the host will be where the daemon is running and where containers and images will reside. So the host could be our home machine, host could be a remote server, and host could be a Elasticsearch EC2 EC2 instance in AWS, or it's a virtual machine in Azure. And if we can hit the command, we can either we can hit the docker CLI command, or we can run our compose file onto the host, and then it will the daemon will take that command and then it will do the operations, and all the images and containers will reside in the same machine, same host only. After that comes the registry. So registry is where our images are getting stored. It will be a public registry or a private registry. It will be self-hosted registry or a managed registry. It can be provided by some provider. It can be a Docker Hub registry, which is basically provided by Docker. It can be anything, but it can also be a on-premises. I mean, a registry which we set up ourselves, and we can use it via a private link, or we can use it via private communication or internal call, or it can be a internet-based registry where like DigitalOcean, Docker Hub, uh, GCP registry, Amazon Container Registry, all those things are there. We can use that also as a registry. So now let's talk about if we hit the command, how it works. So suppose if I have hit a command, it will first go to daemon, and then daemon will go to registry. If I have hit a command to run an image, from the client. So what will happen if you see the red lines? Red lines is basically to the pull command. So it will send this command to daemon, and daemon directly send this command to the registry. So how it will go to the registry is basically like if we have not passed anything. Simply if we have passed, suppose there is a nginx image I want to run, and if I just passed nginx latest, what it will do is first it will check into the daemon, into the host machine itself only, in locally. If it checks locally, if the image is already available, then it will spin up the container immediately. If it is not available, it will go to the default docker registry, docker hub, we can say. So by default, if you don't pass any registry in your image, it will directly go to docker hub, and it will check for that image. So the moment it goes to the hub, if the nginx image is not available in your local registry, it will go to docker hub and pull that image. The moment it pulls the image, after that it will spin up a container here. Now suppose if I have sent a run command here, so the run command will also go to daemon, and then daemon will check for the image. If image is not available, it will pull the image from the registry and then spin up the container. Again, if I have push the command, if I have run a command for docker build, so what will happen, build this command will send to the daemon with the docker file configuration. So with the docker file configuration, it will check for the base image, which will pass in our docker file, that we will discuss later also. It will check in the base, it will check for the base image, and it will take the base image, and it will start building the image. Once the image got built, it will store in the images. And if you have run the command to push, it will push the image to hub, whatever registry you are using. If you are using your private registry, if you are using docker hub, it will push that command to there. Now we talk about virtualization and containerization. So, what are virtual machines? Virtual machines are the overlay of our operating system. It encapsulates all binaries, all application-related files, and all libraries to in a image format. After that, runs as a guest OS in our host system. Okay, so if you see here, so these are the app files and binary files, and it is running as a, so this three box, this is a virtual machine, this is another virtual machine. There is hypervisor is basically like it's the virtualization provider software which use which helps us to run that binaries and application libraries, so that it can create a guest operating system. Then below that there will be host operating system, and then our infrastructure. So our infrastructure, I can say our own laptop, our own desktop system, and then their running operating system whatever operating system we are running, if we are running Linux or if we are running Windows, so they will be there. After that, hypervisor software will be running there. So without hypervisor or VMware software, we cannot run our virtual machines in our system. We need at least one virtualization software. Now comes the picture, container. So container, it does not need any operating system to run. It does not spin up any operating system. It runs with application files and then the binaries and libraries. That's all. And it creates a container of it whenever we spin up the docker run command. So what are the architecture of containers? So containers resides in our host operating system with container daemon. As I showed you here, the daemon. So this daemon will be running in our host machine, and then it will be responsible for creating containers, managing them, managing their state, and managing any issue has happened into the container, if it is running properly or not, all those things. So what's the difference between both of them? So the difference between both of them is the guest OS. So in containers based architecture, we don't need to run our operating system. That is basically, suppose if we are running Ubuntu based operating system, what happens when we create a virtual machine? So it creates all the files, it start up all the files, all the dependencies, all the binaries as it do for a host system. So here it will consume a lot of space as well as resources, memory and CPU. But when we come to the container part, it will not spin up it as the operating system. It will not require all the files, all the binaries and libraries for an operating system. It just contains the runtime files. It just contains the files which are required to run an application, whether it is based on Ubuntu, whether it is based on Debian, whatever base it is, and whatever application, suppose if a Java platform or a Python or a Node.js platform, it will just have the runtimes of Debian and then the runtimes of Java, and it needs the application files. So if you see here, it needs application files and then binaries and libraries. That that will be our image. So whenever we'll spin up the image, it will start running all these files. That's all. So it basically saves lot of space and resources, and it's very fast and very quick. We can ship it also. And usually what happens, the one of the very best feature of containerization is basically like we can ship it and it can be running anywhere. Wherever container daemon is running, it can run there also. But the problem with virtual machine based things are that however we have built the image, it can run in that kind of virtual environment only. Suppose if we have built the image on hypervisor, so it can run only in hypervisor based virtual machines. If we have built it on VMware based virtualization system, it will run on VMware based virtualization system. But this is not the case with the containers part. In containers part, wherever the container daemon is running, we can run that Docker image anywhere. Even we can run it on cloud machines also. We can ship it to anywhere, any part of the world, and we can run. Now we will talk about the concept of Docker image and then container, because image and containers are the most talked part in Docker. Okay, so Docker images contains executable application source code as well as all the tools, libraries, dependencies that the application code needs to run as a container. As I told you earlier, so the image is a stateless component of Docker where it contains the files. The moment you spin up a run command or you start a container, it becomes stateful. Why? Because now all the processes are running in the container. The moment image is residing as a image, as a Docker image, it does not run any process, it does not do any operations. So that's why it's a stateless at that time. The moment we spin up a container of on top of that Docker image, it becomes stateful. So a Docker image contains all the executables, libraries, and dependencies of the application. Suppose if there is a Java application we have created, so it will be having all the compiled source code of Java, whatever source code we have for our application, it will be having in the compiled mode, and then it will be having all the dependencies and libraries. Suppose we have used any framework like we have used Spring Boot or Hibernate. So all the related components of Spring Boot and Hibernate will be there in that image, as well as all the dependencies. So, any dependency we have created for that particular, if we have used any plugin in our Java, if we have used any database plugin or MySQL Server plugin. So all these things will be there in the Docker image. Plus, it will be having the base operating system files also. So if we have built that on Ubuntu, or if we have built on Alpine, or if we have built on CentOS, so that runtime file will also be there in that image. Now, when we run the Docker image, it becomes one instance. Simply, we can say that it becomes one host actually, but it's running in very precise and compact size. So it's like the Docker image, whenever we trigger it, whenever we run it, it also becomes an instance. We can go into that, we can go into the terminal of it in a TTY mode, and we can check, we can do ls-l, like whatever Ubuntu, if it's based upon Ubuntu, we can run all the Ubuntu based commands in that image. And after that, the containers. So Docker container image is a lightweight standalone executable package of software that has everything you need to run as application. Okay, so basically containers are the image. Okay, so they are the image whatever we have created in a lightweight mode. So whenever we run the container command, it uses the image, and then it spins up all the processes the moment we have hit the Docker run command. It spin up all the processes available in that particular image. So it will check for the code, runtime, system tools, system libraries, and settings. Whatever settings we have passed, whatever ports we have exposed, whatever volumes we have attached, all those things come into the picture, and they will start processing based on the data we have provided at the time of container running. So container is basically, we can say here, it's a zip which takes the files whatever we have kept in our image, and it start running it start processing, it start operating, it's giving us the kind of machine running behind the scene, and it is doing all the operations what we have defined in our Docker image. So throughout this training we'll cover some add-on topics also. It's like debugging and troubleshooting Docker CLI. So there are a lot of issues happened when you run the Docker CLI command. You need to know how to debug it whenever you are trying to create a container, but it is failing because of some issue, because of something, some data is missing, or because of some configuration you have not passed properly. So these things also we'll discuss. And uh, we'll talk about efficient ways of writing Dockerfile. What are the industry based best practices to write the Dockerfile? How you can write Dockerfile for a company, for an organization. So if we go there for a production grade environment, how we write our Dockerfile. I'll show you the live demo. I'll give you the details. I'll give you the data, how we used to write in the best practice in a secure and a compliant way. Then we'll talk about very latest feature of Docker, which is like multi-stage Docker build, where we'll talk about how multi-staging works in Docker, how we can reduce the image size using the multi-stage. And then we'll talk about Docker in Docker also. So Docker in Docker is basically where we talk Docker image is a Docker container is running inside a container, and we can run the Docker commands, Docker CLI, all those things in the Docker container itself also. I'll give you the so I'll showcase you how it works, and I'll give you a brief idea about how you can create a Docker in Docker using the Docker file. Then we'll have projects here. In that project, we'll be writing the Docker file for Java Spring Boot based container application with Maven, and then we'll have a Python container based application using Flask. We'll write Docker file for that also, and then we'll try to run and create that container for them. And then we'll build the multi-stage Docker image for Node.js application, and we'll do the comparison between the traditional way of Docker building and then the multi-stage based Docker building. For your prerequisites, we need high-speed internet and desktop, as well as system requirements will be here very precise. It should be minimum 2 core CPU and 4 GB memory, because Docker will be running. many processes behind the scenes. It will be running daemon, it will be running our images. Our containers also require resources. So for that, we need 4 GB of memory at least, and we need storage as 100 GB for doing many for storing the images, for doing other operations. Will create image, or for all those things we need storage as 100 GB. And Hyper-V and container windows should be available for Windows OS. So hypervisor in Linux, it's by default available. In Windows, we have to enable it. These are the additional course resources where we can find the documentation for Docker, Docker Hub, Docker Registry, and then the mock interviews. Mock interview questions are here. You can take reference from it. And certifications, Docker provide two kind of certifications. One is Docker Certified Associate and Docker System Administrator. These are the two certificates Docker provides actually. And then we'll also provide you the course completion certificate, where we'll give you the accreditation for completing the course successfully and getting knowledge of Docker, acquiring knowledge, and then having hands-on experience for Docker.